solve the equation 8 sine square theta plus 6 cos theta plus 1 equals to 0 for 0 until 180 degrees. So for this, we see that the equation contains sine and cos. To solve this kind of equation, we have to make the same trigonometric function. So express it in single trigonometric function. So I can change sine into cos using the identity of sine square theta equals to 1 minus cos square theta. So we can solve this. So 8 sine square, so 8 1 minus cos square theta plus 6 cos theta plus 1 equals to 0. And then I simplify 8 minus 8 cos square theta plus 6 cos theta plus 1 equals to 0. And then it is negative 8 cos square theta plus 6 cos theta plus 9 equals to 0. I multiply everything by negative 1. So 8 cos square theta minus 6 cos theta minus 9 equals to 0. And then we have quadratic equation. Now we can simply express cos theta as a, for example. So I have 8a minus 6 square minus 6a minus 9 equals to 0. So I can factorize. So 8a and 9 to become 6. We try for a and 2a. And then 9 is 3 and 3. So to have negative 6, I have to put negative here, negative 12. Yeah, 4 times 3 is negative 12, and 3 times 2 is negative 6 here. Plus, I put it plus, so negative 12 plus 6 is negative 6. So that means from here we can have a equals to negative 3 over 4, or a equals to 3 over 2. So in this case, we replace it back to the function cos theta equals to negative 3 over 4, or cos theta equals to 3 over 2. This value is not possible, yeah, since cos theta maximum is 1. Yeah, so cos cannot be greater than 1. So that's not possible for the second answer. So now we can find it in the cos theta equals to negative 3 over 4. So we know that cos is negative will be in the second quadrant and in the third quadrant, cos negative. So let me try to find the value of cos inverse 3 over 4. I will ignore the negative, yeah, to find the angle and in quadrant 1 to find the acute angle. So this is in degree. Make sure your calculator is in degree mode. So cos inverse of 3 over 4 equals to 41.4 degree. So that means for cos theta equals to negative 3 over 4, the theta will be equals to the second quadrant will be 180 minus 41.4 plus the period. So this is equals to 138.6 plus k times 360. For k equals to 0, theta is 138.6 degree. If I put k equals to 1, it will be greater than the domain, so no need to check it. For the third quadrant, cos theta equals to negative 3/4. So theta will be 180 plus 41.4. Yeah, 180 plus the angle in the first quadrant. So this is greater than 180. This is to 1.4 plus k times 360. So in this case, even when k equals to 0, the theta is 221.4 degree. And this is greater than the domain. So we have to ignore. So the single answer for this is only 138.6 degree. Number 2, prove the identity sin theta per sin theta plus cos theta plus cos theta over sin theta minus cos theta equals to tangent square theta plus 1 tangent square theta minus 1. So from here, we have to prove from the left side to the right-hand side. So from the left-hand side, I have sin theta plus cos theta sin theta minus cos theta. So from here, I can make the denominator the same. So it's sin theta plus cos theta sin theta minus cos theta. And because I multiplied the denominator, so the numerator should be multiplied by sin theta minus cos theta. And for the second fraction, cos theta multiplied by sin theta plus cos theta. So in here, I can have sin square theta minus sin theta cos theta plus cos theta sin theta plus cos square theta over the bottom, the denominator will be sin square theta minus cos square theta. Yeah, this will fulfill the spatial factorization. A plus b times a minus b equals to a square minus b square. So this is a square and this is b square. And then we can simplify. I can cross this. So I have sin square theta plus cos square theta over sin square theta minus cos square theta. If we check, the right side should be tangent plus 1 and tangent minus 1. So I can divide both sides, both numerator and denominators, by cos square theta. So I multiply this, and I have sin square theta over cos square theta plus cos square theta over cos square theta over sin square theta over cos square theta minus cos square theta over cos square theta. And this is equals to tangent square theta plus 1 over tangent square theta minus 1. And this equals to the right-hand side. Hence, find the exact solution for the equation for 0 until pi. So from the previous question, we can have this form as the tangent square theta plus 1, tangent square theta minus 1. Check it. Is it correct or no? Tangent square plus 1, tangent square minus 1. Yes, correct. So this one for the left side and for the right side equals to 2. So equals to 2. Now we solve this and find the theta for between 0 until pi. So I can cross multiply tangent square theta plus 1 equals to 2 tangent square theta minus 2. And then I can simplify. I have tangent square theta equals to 3. So tangent theta will be square root of 3, or tangent theta will be negative square root of 3. Don't forget that this is plus and minus, yeah? When you have the tangent square theta, and then when you root it, you have the plus and minus, two possible answers. So that means I have to find, from the left side, I have to find the answer in quadrant 1 and quadrant 3, because tangent theta positive is in quadrant 1 and 3. For the right one, I have to find in the quadrant 2 and quadrant 4. But we know that the answer of the region should be only quadrant 1 and quadrant 2. So we are finding the quadrant 1 and quadrant 2 only. So the theta in here is the tangent inverse of root 3. So the theta will be equals to 60 degree, or in radian it's pi over 3 plus k times pi. The period of tangent is pi. For k equals to 0, the theta will be equals to pi over 3 radian. And then for the second quadrant, because this is square root of 3, yeah, the same value, so I can just use the theta will be equals to the pi over 3 in the second quadrant is pi minus pi over 3, k pi. So the theta will be equals to 2 over 3 pi plus k times pi. And for k equals to 0, theta will equals to 2 over 3 pi. So that's it. Only two answers for this question. If they expand the domain until 2 pi, so we have to find another value. So we can put the k equals to 1. So theta is pi over 3 plus pi equals to 4 over 3 pi. And also in here, k equals to 0, equals to 1. So theta equals to 2 over 3 pi plus pi equals to 5 over 3 pi. So there are two additional answers if the domain is expanded. Next, number 3. Show that the equation may be expressed in the form of a sine squared theta plus b sine theta plus c equals to 0, where a, b, c are constant to be found. So we can use this, yeah. 1 over sine theta plus cos theta, 1 over sine theta minus cos theta equals to 1. I can make the denominator the same again. So sine theta plus cos theta, sine theta minus cos theta. So this one multiplied by sine theta minus cos theta. This one multiplied by sine theta plus cos theta equals to 1. Simplify, I have 2 sine theta, and then I can cancel the cos. They are cancelled out. And the denominator will be, this is a plus b, a minus b, so a squared minus b squared equals to 1. And then I can cross multiply sine squared theta minus cos squared theta. Again, we have to express it in single trigonometric function. So I have to use cos square theta equals to 1 minus sine square theta. So 2 sine theta equals to sine square theta minus 1 minus sine square theta. So 2 sine theta equals to sine square theta plus sine square theta. So this is 2 sine square theta minus 1. And then reduce to the quadratic. So 2 sine theta minus 2 sine theta minus 1 equals to 0. Okay, from here, this is for A. And then for B, hence solve the equation for 0 until 360. So we can change this expression using the previous answer. It's 2 sine square theta minus 2 sine theta minus 1 equals to 0. So we cannot factorize this equation, this quadratic equation, yeah? So we have to use the quadratic formula. So it's sine theta equals to minus b plus minus square root of b squared minus 4ac over 2a. So that means we have a equals to 2, b equals to negative 2, and c equals to negative 1. So it's 2 plus minus square root of negative 2 squared minus 4 times 2 times negative 1 over 2 times 2. So 2 plus minus square root of 12 over 4. That means sine theta equals to 2 plus root 12 over 4, or sine theta equals to 2 minus root 12 over 4. For the first one, 2 plus root 12 over 4 is greater than 1. So it's 1.37. So this is not possible. So that means from this side, we have sine inverse equals to negative 21.5. But we have to find the region between 0 until 360. So quadrant 1 until quadrant 4. So we cannot use the negative value. We find this angle in, since the theta is negative, yeah, sine is negative. So that means it will be in quadrant 3 and quadrant 4. Because 2 minus root 12 over 4 is negative. So the theta in quadrant 3 will be 180 plus 21.5 plus the period. So this is equals to 201.5. For k equals to 0, the theta is 201.5 degree. Yeah, we cannot put any other values for k because it will exceed the region. And the second answer in the fourth quadrant will be 360 minus 21.5. So equals to 338.5 plus k times 360. So equals to 338.5. So k equals to 0. So there are two answers. Show that. Okay, from here, the left-hand side should be, I make the denominator the same, 1 minus sine theta, 1 plus sine theta. So sine theta multiplied by 1 plus sine theta minus sine theta multiplied 1 minus sine theta. And then I expand sine theta plus sine square theta minus sine theta plus sine square theta over 1 minus sine square theta. So in here I can cancel sine. So I have 2 sine square theta over 1 minus sine square theta is equals to cos square theta. So I can change it into cos square theta. And sine square over cos square is tangent square theta equals to right-hand side. Hence, solve the equation equals to 8 for 0 until 180. So that means I can change this to tangent square theta equals to 8. So tangent square theta equals to 4. So tangent theta will be equals to 2, or tangent theta equals to negative 2. From here, the left side I have the theta is tan inverse of 2. This is degree. So it's 63.4 degree plus k times 180. If k equals to 0, the theta is 63.4 degree. And tangent positive in quadrant 1 and quadrant 3, but the region is only for quadrant 1 and quadrant 2. So we can no need to find the quadrant 3. So from the right side, tangent negative, quadrant 2 and quadrant 4. So we're looking for only quadrant 2. So the theta in quadrant 2 is, this is negative 2, yeah, so the same as this. So that means it's quadrant 2 is 180 minus this one, 63.4, plus k 180. So it's 180 minus 63.4. So 116.6 plus k 180. So for k equals to 0, theta equals to 116.6. That's it. Fine. Given that for tangent x plus 3 cos x plus 1 over cos x equals to 0 without the calculator, show that sin x equals to negative 2 over 3. So from here, I can change tangent. So for tangent is sin x over cos x plus 3 cos x plus 1 over cos x equals to 0. And I make all the same, cos x. So for sin x plus 3 cos x times cos x plus 1 equals to 0. So that means I have 4 sin x plus 3 cos square x plus 1 equals to 0. And then I have to change the cos square x. So 4 sin x plus 3 cos square x is 1 minus sin square x. So that means I have 4 sin x plus 3 minus 3 sin square x plus 1. So I have minus 3 sin square x plus 4 sin x plus 4 equals to 0. And I have 3 sin square x minus 4 sin x minus 4 equals to 0. We try to factorize. So 3 sin x, this is sin x. And then to make it 4, I have to multiply 2 and 2 here. So this is minus 6 plus 2 become minus 4. So that means sin x will be equals to negative 2 over 3, and sin x equals to 2. So this is not possible. So the solutions are only this. Shown, yeah? Hence, showing all necessary working, solve the equation, this and this, for 0 until 180. So the expression here, the same as the expression on the top. The difference only, this is x, and this is x minus 20. So we just replace the solution. The solution is sine of 2x minus 20 equals to negative 2 over 3. So that means we have to find the values of x in the quadrant 3 and quadrant 4, because the sign negative on the quadrant 3 and quadrant 4. So that means the 2x minus 20 is sine inverse of negative 2 over 3. So if I find the sine inverse of 2 over 3, I have 41.8. So that means this will be equals to 180 plus 41.8 for the quadrant 3 plus k times 360, yeah, plus the period. On the quadrant 4, I will have 360 minus 41.8, and it's this value, plus k times 360. So that means I can have 2x equals to 241.8 plus k times 360, or 2x equals to 338.2 plus k times 360. So x is, I divide by 2, 169.1, or this one, 120.9. So for k equals to 0, this is plus k 360, 180. For k equals to 0, x is 120.9. For k equals to 0, x equals to 169.1. So we have all the answers in the region. Six, prove the identity 1 over cos x minus tan x squared equals to 1 minus sin x over 1 plus sin x. So from the left-hand side, we can expand this into 1 over cos square x minus 2 tangent x over cos x plus tangent square x. And we have to change everything into sine. So 1 over cos square, I can use cos square x equals to 1 minus sin square x. So 1 minus sin square x minus 2 tangent. Tangent is sin x over cos x over cos x plus tangent is sin x over cos x squared. So simplify 1 minus sin square x minus with 2 sin x over cos square x plus sin square x over cos square x. So we can see that the last two terms contain the cos square x, so we have to change again. Minus 2 sin x over 1 minus sin square x plus sin square x over 1 minus sin square x. So from here, I can combine into 1 minus 2 sin x plus sin square x. over 1 minus sine square x. If we see the denominator has a special form, 1 minus 2y plus y squared. If we do the completing the square, I can have 1 minus y squared. So I can change it into 1 minus sine x squared over 1 minus sine square x. So I can rewrite as 1 minus sine x, 1 minus sine x over, this is a square minus b square. So it will be a plus b, or 1 plus sine x, and a minus b, 1 minus sine x. So we can cancel one of them. So into 1 minus sine x over 1 plus sine x. So this is equals to the right-hand side. Yeah. The important part in here is the changing from this into this. Yeah, you can use the completing the square form if you forget. This is sine square x minus 2 sine x plus 1. So I can change it, yeah, y square minus 2y plus 1. So this is y, we prepare the bracket, square. Yeah, this is minus 2, so it become minus 1, and then minus 1 square. So this simplifies into y minus 1 square. Yeah, we can cancel this. Yeah, so we replace back the y into sine x, so it's 1 minus sine x. Yeah, this is 1 minus y. The same thing. So I just rewrite as 1 minus sine x, and then I can cancel the 1 minus sine x here. Hence, solve the equation 1 over cos 2x minus tangent to x squared equals 1 over 3. So the form of this will be the same, except for the x into 2x, change into 2x. So I can use the form. So this will be 1 minus sine 2x over 1 plus sine 2x equals to 1 over 3. So cross multiply, 3 minus 3 sine 2x equals to 1 plus sine 2x. And then I can simplify into 4 sine 2x equals to 2. So sine 2x equals to 1 over 2. Now to solve this, so sine 2x equals to half, positive half. That means the answer should be in quadrant 1 and quadrant 2. So that means 2x will be equals to sine inverse of half is equals to 30 degree or pi over 6 radian. So that means in the first quadrant, it will be pi over 6 pi plus k times 2 pi. Or in the second quadrant, the 2x will be equals to pi minus pi over 6. Yeah, 180 minus 30. And then plus k times the period, 2 pi. And simplify into pi over 12 plus k times pi. In this case, this is 5 over 6, yeah? So become 5 over 12 pi plus k times pi. So for k equals to 0, x will be equals to pi over 12. For k equals to 0, x will equals to 5 over 12 pi. If we put k equals to 1, it will be more than 1 pi. So we cannot add the period in this solution. So we only have two solutions in the given region. Seven, express the equation sine to x plus 3 cos to x equals to 3 sine to x minus cos to x in the form of tangent to x equals to k, where k is a constant. So first, we have sine to x plus 3 cos to x equals to 3 sine to x, I expand here, minus 3 cos to x. And then I will simplify. So I will have negative 2 sine to x equals to negative 6 cos to x. And if I divide the sine and cos, so sine to x over cos to x will be equals to negative 6 over negative 2. So that means the tangent to x equals to 3. So this is the first answer. And for the second one, solve the equation for negative 90 degree until 90 degree. So we solve the tangent to x equals to 3. So that means it will be in the first quadrant and the third quadrant, yeah, tangent positive. So that means the 2x will be, find the tangent inverse of 3 equals to, this is degree, yeah, degree mode. So tangent inverse of 3 is equals to 71.6 degree. Okay, I write in the 2 decimal places. So 5, 7. So the first quadrant is 71.57 plus k times 180, the period of tangent. And in the third quadrant, it will be to x equals to 180 plus 71.57 plus k times 180. So we have x equals to, we divide by 2, so 35.78, so this is 0.8, plus k times 90, or x here, will be 125.8 plus k times 90. So now, if we put k equals to 0, x will be 35.8 degree, yeah, which is in the first quadrant. Now, so we take this value. For this one, when k equals to 0, x will be 125.8. This is greater than the 90, so we reject this. And then if I put k equals to negative 1, I will have x equals to 125.8 minus 90 degree. So I have 35.8, so which is the same as the first answer. Now, if from here I put k equals to negative 1, I will get 35.8 minus 90 equals to negative 54.2 degree. So we take this because this is in the region of between negative 90 until 90. If I find k equals to -2 in here, I will get the same thing. So negative 54.2. So we take only two values. So the solution are negative 54.2 and 35.8 degrees. Yeah, that's the solution for this in the given region. So this is the last question in this worksheet. Thank you, guys.